For today's lesson, we're going to organize and display data using bar, line, circle graphs, and possibly dot graphs. As we look at bar graphs, it's important to know when we use them. You're going to use a bar graph to display the data so that you can organize things into categories. When you have everything in a category, you can quickly compare these categories. In order to construct a bar graph, you need either horizontal or vertical bars. There are single bar graphs and double bar graphs. We're also going to be working on solving percent problems today. Whenever you get stuck with a problem, you're going to use word equations to help set up these answers. So for example, if you want to figure out a percent increase, write the word increase in the line percent increase times the original or total, whatever you're given, is going to be equal to the number increase. So this will be a number on the right-hand side of your equal sign. It's also possible that you're going to be asked to do percent decrease. So you put the word decrease in and decrease. So the words that you write in your equation need to match. Once you have set up these word equations, you can then solve your equation to answer the questions. For question A, which ingredient contains the most fat? So this chart shows you what the fat content is in a sandwich that we are creating. The most fat is the one that extends the furthest along. So it looks like mayonnaise has the most fat. Now, how many more grams of fat are in ham than are in turkey? So that means we're going to be doing a subtraction. So read in the ham has 6 grams of fat. The turkey has 3 grams of fat. We want to know how many more grams, so we're going to do subtraction. 6 minus 3, that's going to be 3 more grams of fat. And now as we look at question C, how many total fat grams are there in this sandwich? Total means that we're going to add. So you take your bread, which is 1 gram of fat, plus you're going to add the 6 from the ham and the 3 from your turkey. Cheese, 9 grams of fat, and of course mayonnaise is 11. Add them all up and you will have your 30 grams of fat. There we go. What percent of the total fat grams in the sandwich are from turkey? Now this one, we're going to set it up as a ratio. You take your turkey fats and you divide it by the total number of fats. So this one's fairly simple, straightforward to set up. So there are 3 out of 30 that are going to give you the ratio, but the ratio is reduced to 1/10. And when you do division, you have 10% of your sandwich. The fat is from the turkey. All right, answer questions 1 and 2. Then we'll look at example 2. For example 2, in which year did State College have the greatest average attendance for basketball? So let's look at this a little bit more closely. Notice that football is in red and basketball is in orange. We have the year across the bottom and the average attendance in thousands on the side. So they didn't have 20 people attending a football game in 2001, they actually had 20,000. So now that we understand the graph a little bit better, this is one of those double bar graphs. In what year did State College have the greatest average attendance for basketball? So you want to check out the orange lines, and the orange lines are highest in 2003. Question B, on average, how many more people attended a football game than a basketball game? So again, that means that we're going to have to do some subtraction because we want to look at the difference. So for the basketball game and the football game, we have 20 in 2001 minus 13. Now you really know that those are not 20 and 13. There were actually 7,000 more people attending football than basketball. Finish up with questions 3 and 4. Question 5 and 6 are using bar graphs again. So give question 5 and 6 a try. Afterwards, let's talk about the percentage of the order we're baked ziti and go ahead and work on this problem. To find the percentage of the orders that were baked ziti, you're going to take the number of orders of baked ziti and divide it by the total number of orders. So make certain you finish this problem. For question C, what percent higher did SUV-Y earn on safety than SUV-X? So this is where we're going to use our little table. We have percent. Let's put the word higher in that little line, and then we're going to times the original, and that's supposed to equal the number of cars that were higher in safety. Well, SUV-Y had 90, SUV-X had 70, and when you subtract, you get a 20. So we're looking for the percent higher. I'm going to put X there, times the original, that would be 70, and that's going to equal the number that was higher, and there's your 20. Do your division. X is equal to 20 over 70, and 20 over 70, and then you will have to rewrite 20 over 70 as a percent. Now let's turn our attention to line graphs. So line graphs are used to display data that changes over a period of time. So there's your big difference. We're looking at a period of time. When you use your line graph, you can quickly compare rates of change over periods of time. To construct your line graph, you plot dots, you connect those line segments. Now there are two types again, single and double line graphs. So when we look at example 1, notice that we have temperature on one day, starting from midnight all the way to 8 p.m. The time is on your independent axis, and temperature is on your dependent axis. The question is, at what time is the temperature lowest? So you're looking for the lowest value for the temperature, and that's going to be midnight. During which 4-hour time period did the temperature increase the most? So do a quick comparison. Try to figure out which one of these has the steepest slope. And the steepest slope is going to be the one that increased the most. So according to our picture, it increased the most from 8 a.m. to noon. For question C, use the graph to estimate the difference in temperature. So difference again means that we're going to subtract between 4 a.m. and noon. So find the temperature at 4 a.m. and that was 62 degrees. Find the temperature at noon, and at noon we have 80 degrees. Subtract 80 degrees minus 62 degrees and you're left with 18 degrees. Question D. What was the percent increase from 4 a.m. to noon? So use words. Percent increase times the original temperature in this case is going to be equal to the number increase. Now we found the number increase in part C, so that's going to be 18. The original temperature occurred at 4 a.m., so that's going to be 62 degrees. And the percent increase is what we're looking for. Do some division. Your percent is 18 over 62, and then you're going to rewrite that as 29%. Example 2 is a double line graph. So you have to read which one each of these lines represents. So station A is in the red color, station B is in the blue color. Station A also has diamond marks, station B has circle marks. In which month did station A charge more than station B? So you want to look at the differences and figure out when is the red line above your blue line. And to me, that looks like it happened in May. During which months did station charge the same for gas? So we want to know which month the lines are intersecting. And it looks like we have two answers for that, April and January. What was the percent decrease in the cost of gas for station A from April to November? So in April, that was $1.26. Yes, this is a really old book. In November, it was $1.22. So percent decrease times the original amount is going to be equal to the number increase. So your percent decrease is what I'm looking for. The original amount is 126, and the number of decrease is going to be 4. So this is going to be set equal to 0.04, in fact. Now, do your division. P equals 0.04 divided by 1.26. And we end up with 3.2%. All right, I hope those percent problems are getting better for you. Now, so far we've looked at bar graphs, line graphs, and we're going to be hitting some circle graphs. Bar graphs organize categories and are used for comparison. Line graphs are always associated with time, and circle graphs are going to organize parts of a whole. So go ahead, finish up this problem set. All right, here we are with our circle graphs. So circle graphs, as I said, are used to compare parts of a whole set. When you construct a circle graph, you have to draw an entire circle, and it's going to represent 100% of the data. Each sector is going to represent a percentage of the data. Things that are in your circle are labeled with percentages or amounts, and it's certain you know which one you have. To calculate the number of degrees, there are 360 degrees in a circle. So we're going to have a fractional amount times 360 is equal to the number of degrees in the circle. So if you know that you have 1/3 of a circle, that's 1/3 of your 360, that's 120 degrees of the circle. For example 1, notice we are making some punch. There are 4 ingredients: your ginger ale, your orange juice, your sherbet, and a little bit of lemon. Now, which ingredients are present in equal amounts? So look at your graph, see which ones have the same pie shape. And what you'll notice is that would be your lemon sherbet, and you also have your pineapple juice. Those are equal amounts. Lemon sherbet and pineapple juice. Okay, now if you use 4 gallons of ginger ale, how many gallons of orange juice should you use? So 4 gallons is half of this concoction, and I want to know what is a quarter more of that 4 gallons. So if we have that the ginger ale is 4 and orange juice, I need half as much, so the orange juice is equal to 2 gallons. If you use 4 gallons of ginger ale, how many gallons of lemon sherbet should you use? Now, if we are using 2 gallons of our orange juice, and the orange juice is twice as big as that lemon sherbet pie, then you need 1 gallon of your lemon sherbet. All right, go ahead and complete this assignment.